Unit 5, inverses. Inverses is very simple to do. It's what you do after the inverse, which gets a little bit crazy. That is an inverse. An inverse is when you switch x and y. Literally when you switch x and y. What? No. Okay, so when you switch x and y, that's all that happens. You wherever x is, wherever y is, you just literally switch them and put them in the other spot. It's as simple as that. Don't make it more complicated, okay? My analogy is Indiana Jones. Maybe it's a little too old now, but there's something on the crystal and the whatever.
It's like on a pedestal.
And they switch it out real quick in the same spot, right? So right here, I'm going to take the inverse of this, okay? What would the inverse of y equals x plus 2 be?
It would be x equals y plus 2.
Yes, x equals y plus 2. Oh my goodness, that's as hard as the inverses get, as far as switching them, okay? Did the 2 do anything?
No.
No, because he's not an x or a y. You literally just rewrite the thing with the letters in a different spot, right? No math is involved here. Now, here's the problem we have though. Anytime you say an equation, you normally say y equals the equation. So now, what happened?
Oh, we switched.
We just screwed it up, right? We fixed the inverse, but now we need to be able to say y equals, right? We need to be able to say what y equals. So that's why we did yesterday's thing of how to solve for y. It's all coming together. See the big picture? Oh, all right. So how would I solve for y?
You have to get it by itself, so subtract 2 from both sides.
Exactly. I need to get this y by itself. There's a plus 2. I'm going to undo that by opposite. Minus 2, minus 2. These cancel out. I have x minus 2. In fact, actually, I'm going to see if you can equals y is what I was going to write. But let's see if you can handle 2 steps at once. I'm just going to, anytime I get y by itself, like right now, I know y is by itself. I'm going to say y equals x minus 2. And that's my answer. Are y'all okay with that switch?
Yeah.
Okay. I did it yesterday a little bit, but I don't want you to get confused of the switch between x and y and the flip of when I write the equation. You know what I'm saying? Like across the equal sign. That's a very different, just sword fight. That's a very different type of situation. I did not switch x and y again. I just wrote the y down over here and I wrote this side down over here. Just switch sides. Okay, careful with that. But anyway, now we have y equals 2x. Take the inverse.
So 2x equals y.
2x equals y is the most common mistake people make.
Why?
Why is because, what are you switching?
The x and the y.
X and y only.
Only.
Only. Okay? So I just take the y, I just take the x, and I switch them. Everything else stays in the exact same spot. So I have x equals to y. Switch, right? Okay. Again, that's very different than just writing the entire thing with just the letters. Okay. So cool. Whoa, gosh.
Aggressive.
Cool. Okay. Aggressive teaching. What now though to solve for y or be able to?
You just divide by 2.
Opposite. It's being multiplied by 2, so I divide by 2. I divide by 2. Cool. So now I have y by itself. I can say y equals. This is interesting.
Oh, because there would be a 1 where the x is, so it would be 1.
It would be 1/2 x, because how many x's are right here? There's one of them, and there's a 1 in front of that x. So you could do that if you want, just to kind of be a placeholder. We did that yesterday, and it's just 1/2 x. Cool, done.
Yeah.
Right? Now, technically, there's one extra little thing here that I might want you to add to your notes. Have you ever seen this little sign before? That means inverse. Okay, so the little power of -1 sign, as far as it's like a little stamp or a little indicator or a little red flag. Hey, that's the inverse. Hey, that's the inverse. Okay. And here's why it's important, because if I look at this, like look up here real quick, just stop writing this stuff down. Y equals x plus 2. Y does not equal x minus 2, or you know what I'm saying? This is what y equals. So I'm saying that's the inverse of y. It's like my language or my stamp, my seal of approval of what I just did. It's like letting you know, hey, this is the inverse of that, right? Cool. All right. And that is inverses. So there we go on that. Cool. Now I'm going to take the concept of inverses and apply it to what we did yesterday. This is number 12 on your paper from yesterday. Okay. So I have this thing, and I'm going to start off in brown here. I need to solve for y first, which is the step that I gave you. Now, the problem we're about to do is very extra, to use cool lingo from a year and a half ago, I guess. It's going to be involved, but I'm trying to show you something that's much more difficult than anything else I'll throw at you. So you'll be like, oh, that's it? Okay, cool. And everything else you'll see after this is going to be easier than what I'm showing you right now. So buck up, get ready, because you got to bring your math pants here on this one. I don't know, I just made that up. So this is the equation on number 12. The instructions are solve for y. That's the first seal you need to be able to do, and then I'll switch to the red marker and we'll take the inverse. So you'll see the big picture. Okay, so I need to solve for y right here. What do I do first?
You move the 7x.
So I'm going to move the 7x over here. Opposite of that, I'm going to move it over here. Cool. And now I just cancel out. And I have negative 2y equals 7x plus 18. Cool.
So then,
Now, real quick. Actually, no, I'm going to say that for a second. Sorry, I interrupted my own self. What now?
you then divide the -2.
Yes. I have a -2 in front. I'm going to divide by -2. Who am I dividing -2 by? Everybody. I love it. I love it. Yes, everybody by -2. Love it, love it, love it. Here's where the first question came up yesterday. I've never been asked this question. In 10 years of teaching math, it was a great question. Somebody said, why did you not add 7x to this guy?
Because
You see what I'm saying? Just stop real quick and kind of take a step back of why. Now, you might understand, but do you see why that could be a legitimate question?
Yeah.
I was like, oh my God, I totally see why you're confused there. They wanted, let me write in red because this is not correct. They wanted to do this.
which
You
is
see how interesting that is as a teacher? I was super interested. Why is this not possible though?
because it's a y and an x because the variable's right there, so it doesn't. They're two different things and not the same thing.
Well, and so the biggest reason why it doesn't work is you have an equation, right? If I did add 7x over here, how many total x's would I have added to the left side?
-7.
I would have added 14 x's. You see what I'm saying?
Oh.
Right? And that's now, whoa, too many x's. See, it's not balanced anymore. So I have to, if I'm adding or subtracting, very good distinction right here of what the overall answer was. If I'm adding or subtracting, I do it once to this side and once to that side to keep it balanced, because that's how adding and subtracting works. It makes sense. You're adding weight, you're taking off numbers, whatever. So I can't add 14 x's over here and then 7 over here. So that's why I do that, and I pair it up with the thing that's the like terms or whatever, okay? Here though, this is division and multiplication. If I'm if I'm multiplying or dividing, I do it to everyone, because if I didn't divide him by -2, he's too big now, and that's gonna off, you know what I'm saying? So you gotta keep everything the same, divide by -2. That was a super great question there. Okay. We're done now though. We have y equals, one step at a time. What's the sign gonna be? Positive divided by a negative?
Negative.
Negative. We have 7 over 2 does not reduce, so we have 7 over 2x, which is the same thing as that half we had earlier, that 1 over 2. We have 7 over 2. Cool. Same thing. And then positive divided by negative is a negative.
9.
18 divided by 2, 9. Yay. Okay. That is the first half of what I want you to do from the paper from yesterday. Now, I'm going to be a jerk and say, inverse it. Okay? So, you have this equation. You say no, cool. You get a 50. All right.
Oh.
You did half the problem. This is the answer for this. I'm now going to take the inverse. Taking the inverse, very easy. What comes next? Maybe not. Take the inverse. What's the inverse?
Will be x
equals
-7 over 2 y minus 9.
the same thing, but switch the letters. That's it. Cool. Inverse. That's the definition of the inverse. Hopefully you got that part down. No problem. Now, I am now asking you to solve for y that is buried in the biggest way I could possibly throw at you. And this is why I'm saying this is the hardest thing I could come up with. I got a number over here that's being subtracted. I have a fraction that's negative. Oh my goodness, right? But the first step should be easy enough. What's the first step? You should be totally fine with the first step to get y by itself.
You add 9 to both sides.
We got a -9 over here. I'm going to add the 9. I'm going to add the 9. Cool. Now I have x plus 9 equals -7 over 2y. Cool. Okay. This looks nasty, but it's not, and let me explain why. Right here. Okay. So if I have, I'll do it here. If I have 10 equals 2 over 5x. You might have never taught, this is probably maybe the number one thing. If I were to teach you anything this whole year as a math hack, this is definitely top 3 of what I'd want to be able to teach you with this, okay? How would you be able to solve this and get x by itself when you have a nasty little fraction right here? A lot of teachers would teach you a shortcut, which is more confusing. It's one step, but it's more confusing. So I think there's a lot of value in 2 easy steps instead of 1, whoa, step, okay? So I want you to ask, I'm asking you this question, which is a little weird, but what is this 2 doing to x? What is this 2 doing to the x? It's a weird question. It is multiplying by 2. That's what it's doing, right? Because you have this thing, let me write it right here, you know, like where it normally is. This is 2/5 times x. That's what most people see. Y'all see it as this. Y'all see it as 2/5 times x, right? But what is the 2 doing? Ignore this right now. What is that? That 2 is multiplying times 2. Do y'all know how to handle, you know, a 2x?
Yeah.
Yeah, no problem. What is the 5 doing to the x? Dividing it by 5. See what I'm saying? Right? Because it's being, you know what I'm saying? Dividing by 5. If I only had that, it would look like this. Right? Or 1/5 of x dividing by 5. You see what I'm saying? These are both happening at the same time. And that's why this looks like this, okay? And if you try and handle it at the same time, it gets confusing and weird. I'm going to handle them 2 different times, okay? How would I'll use a different color now. How would I get rid of a divide by 5? Multiply by 5. Y'all know how to do that. Don't freak out. I'm going to take this whole thing, times it by 5. And I'm going to take this whole thing, times it by 5. Because if I do something to one side, I got to do it to both sides. You know what I'm saying? All right. So what is this now? 50 equals what?
2x.
2x. Now, if you didn't see this immediately, here's my pop quiz to you right now that might blow your mind. Get your calculators ready. You might need them. I don't know. What is 87 divided by 5 times 5? You should need no calculator for this.
87?
But it's 87. You see maybe why?
Yeah.
Isn't it 5?
You just
Cancel out the other 5.
Right. I took 87, I divided it by 5, and then immediately undid the divide by 5 by timesing by 5, right? So if you did this in a calculator, oh, my phone's right there. If you did this in your calculator, you would do 87 divided by 5, which is like 17.4 or something, and then you'd multiply it by 5, and you'd be right back to 87,
Wow.
right? So instead, and here's my analogy, what's 87 plus 5 minus 5? It's the same thing,
87.
right? It's 87. Please don't be like 87. Okay, 87, 88, 89, 90, 91, 92, 92. 92 minus 5, 92. Oh, 87. See what I'm saying? Right? So don't do that. This is the math shortcut type stuff. Oh, just don't do that. And it just is that. You see what I'm saying? Look for these things that cancel each other out. So here, I am dividing by 5 and multiplying by 5. Those cancel out, and you're left with 2x, which is great, because look at this is way easier now. How do I get rid of a times 2?
You divided it.
Oh my goodness, and now we're back to
10.
x equals 25, right? Easy. So now, back to this final question, and then we're done. How do I get rid of this negative 7 over 2? Don't do it all at the same time. What do I do? What should I get rid of first?
The 7. No, the 2.
You could try and get rid of the 7 on top first, but I like to get, you still have a fraction, you still have a divided by 2. Let's get rid of the fraction. That's usually what is always going to work out the best. Now, how do I get rid of a divided by 2?
You multiply.
I multiply by 2. Big question. Who do I multiply by 2? Everybody, exactly, okay. I am multiplying everybody by 2. Just like here, remember a few minutes ago, I guess. This was, I needed to divide by 2 to get rid of that to everybody, right? Now here, I need to take this thing, I'm gonna use a different color, right? I'm gonna take this guy and I'm gonna multiply it by 2, okay? So that's easy enough on this side, right? Those things, they cancel out just like we just talked about. So I have negative 7y, because those canceled out like we just talked about. But over here, I multiply everybody by 2. What everyone does You might do this at 2 at some point. I don't know. Here's what the wrong thing. This is what people do. This is wrong. I'm about to write down. Here's what everybody does. They're like, okay, times 2. Yeah, times 2. Times 2. Awesome. I times by 2. Done.
You forgot the 9.
Okay, everybody. Everybody has to be times by 2 because to keep things in balance, everything has to scale up to stay the same, right? So if this 9 slips through the cracks and just is still a 9, it hasn't been, increased. So anyway, I like to do this and then put the 2 there. So it's like distributing, you know what I'm saying? If you want to think of it like that. But you just do it to everybody. I don't care if you write it like this. It's x times 2 is 2x. 9 times 2, 18. And then you got your thing right here, okay? Now, the last step, and we're done. How do I get rid of a negative? Multiply by negative 7.
You divide by negative
Divide by negative 7. On who?
Everybody.
Everybody gets a divide by negative 7. You get a divide by you. All right.
You get it.
So I get this right here. I have negative 2 over 7x. 18, or positive and a negative is a negative. 18 divided by 7 doesn't work, so I have an 18 divided by 7 equals y. Cool.
Wow.
Now, when I did this 2 classes ago, I was like, oh, cool, these cancel out. And I wrote y equals, and I started writing, and it just confused everybody because there's too much going on, so that's why I kept it normal, right? But my answer is y equals negative 2 over 7x. I'm just rewriting this in my answer form that you'd see like on a multiple choice section. There you go. Now, there's one thing here, so to see if y'all catch it. There's one tiny little problem here that's technically wrong, but just could, what? Ooh, no, get rid of this. I do need the 7 there because they are both being divided by 7. I'd have to multiply by them. I couldn't do that. There's one little tiny up in the top.
Oh, you didn't put the inverse in.
Inverse. Okay, there you go. That's it. Okay. Mathematically, we're all fine here, but it's the inverse. And this, even if you look at this, like that should be contradictory. Like, oh, hey, why is this? Oh, yeah, why is also that? Like, what? How? Which one? I don't know. Like, if somebody just came in here, there you go.
Oh.
That's the inverse. Oh, okay. That's why. That's the inverse of y.
Oh, that's
okay.
why.
Cool. That's it now. You can stop the video now, unless you want to have a bonus mind blow situation right here, and you're like, wait, what? The one thing I'm going to show you guys is this. I'm going to undo this back to here, right, to be 18 over 2 real quick. I want you to maybe look at this and look at that and see if you notice something.
Oh, the 7 and the 2 switch.
Interesting, right? The 7 and the 2 kind of
inverse.
switched because it's an inverse, right? Here we had a divide by 2 situation, but there's a 2. And here we had a divide by 7 situation, and there's a 7. You see what I'm saying? And the 18 is still the 18. But that's interesting. So there's some weird parallel patterns that you might be able to notice that happen with these. I don't want to teach them to you because then people are like, oh, and they think they know the pattern and then they get every answer wrong because they're like, I just switched things around, okay? But if you also notice here, we have the inverse was x minus 2 and the original was x plus 2. See how there's some interesting things you might notice there? And then here, y equals 2x, and here it was half x because of the flipping thing, okay? But anyway, I don't want to get too, if none of that made sense, that's totally fine because I was just trying to blow your minds. Oh, I missed it.
Oh.